Other methods of preparation. In phosphorus-based reagent, acid, alcohol is done, right? Alcohol is done. And after that, we did alkenes. And the last lecture, we did only alkenes, radical halogenation, and MES. Oh. Just to revise a bit, write a question. Please write this down.
So we have to specify the number of products, right?
You have to tell both. You have to show me what are the isomeric monohaloalkenes that will be formed, and also how many will be there. What are those monohaloalkenes and how many? Both of them you have to tell me.
Here should write the number only, or should I write?
No, structures also.
Okay.
What are? Just show the structures. Number तो फिर पता चल जाएगा, right? Done.
Yes, sir.
Okay. So send it to me on WhatsApp. I want to see how you have made the products. What about Abdurrahman?
Yes, sir, done, sir.
Send me the answers now.
Sir, to you personally.
Personally to me. CL.
That's it.
Okay. Thanks. Waiting for Abdurrahman, your answer. See, Abdurrahman, this carbon is also different, right? Yes or no? Huh? Yes, Abdurrahman.
Yes, sir.
That carbon is also different and it also has hydrogen. So basically the replacement of hydrogen takes place. That is why you will draw 4 products. First will be from this carbon. Then we will draw from this carbon. Right. Then we will draw from this carbon and then from this carbon. Okay.
Yes.
Okay. Just keep in mind, if you have something like this, then how many products would be formed? Tell me. CS3, 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 and CS3. Look at the structure and tell me how many products will be formed. Guys, what do you think? How many products will be formed?
1.
Very good. Only one. Hai na? You may see that there are 2 different types of carbon atom. That is true. We have this carbon atom and we have then the middle carbon atom. These are 2 different carbon atoms. But this middle carbon atom, it has no hydrogens. And we need to replace the hydrogen, and then we need to replace hydrogen with halogens, right? So even though there are 2 different types of carbons, you will only get how many products? You will get 1 product. Abdurrahman, aapko aaya?
Yes.
You got this, Abdurrahman? Okay.
Yes.
Chaliye. Right, next. Now we are done with alkane. Now we will look at alkenes. Okay. Now we look at alkenes. From alkenes. So please write. Number one method of preparation from alkene is using halogens. Using halogens, and we use Cl2 and Br2. Anything can be used. So please write when alkenes are treated with halogens. When alkenes are treated with halogens, they undergo halogenation, forming what? Forming vicinal dihalides. Vicinal dihalides. What are vicinal dihalides? See, you have carbon, double bond carbon. Okay, there are, we'll say there are some groups attached here like this. Plus, you're reacting this with Br2. So what is happening here? One of the Br is attaching in this carbon, the other Br is attaching in the other double bonded carbon. So you'll have Br Br. Important points to note. First of all, what is broken? The C bond is broken. Okay, pi bond broken. Okay, what is formed? CBr sigma is formed. CBr sigma is formed. You can write in general what you can write. CX bond is formed in this reaction. Okay, 2CX bond. Please write this down when you're done. Vicinal dihalide. Vicinal means neighboring. So neighboring. So these carbons are what? Vicinal dihalides. The halogens are atoms are in neighbors. Okay, they're neighbor to each other. They are in vicinity. Done, Adil and Abdurrahman, yes, tell me.
No, sir.
Right. Let me know when you're done.
Yes, sir.
Done. Adriel, what about you? Yes, Adriel.
Sir, 1 minute.
Do.
Done, sir.
Done. Write some examples. Both of you can make some products, right? Yes or no? Last one. I hope you have written this part, what is to be done. Pi bond is broken, sigma bond is formed, and let that be your guide and write the products. Let me know if you are getting stuck in some of the question, in any of the question. Okay, don't waste time. Just send whatever you have done. First 3 are done. Yes or no? Tell me.
Yes.
Send it then. Muhammad Umar, you have to send it on my WhatsApp. Okay, Muhammad Umar has joined, and who else has joined? Okay, 3 Learnivio. Muhammad Umar, you have my WhatsApp number, right? Uh-huh. Assalamu alaikum, Sahel. How are you?
Walaikum assalam. I'm fine, alhamdulillah.
Okay. Sorry, I mean, I was not able to update the admin, so I just messaged you the link. Okay. Next time you will get the link from
Okay.
a different number. Okay.
Okay, guys. Sure, no problem.
Yeah.
No problem.
Okay. So, okay. Adriel, make the bonds correctly. Okay. Oops, sorry. Phone was about to fall. Yeah, fine. Answers are correct, but make some proper bonds and at least copy me, na? However I'm writing. Okay. Abdurrahman, Muhammad Umar waiting for you guys. Okay. Meanwhile, Sahal, can you please write this down? From alkenes, you have started a new method of preparation. Huh.
Okay, I'll just write it once again.
Sir, can you show the fourth question?
Fourth question. Wait a second. Wait a second, Sahal. Okay. Let me keep this here. Yeah. Visible now, Umar?
Yes, sir.
Abdurrahman, look at the first question. That is not right. Array. Why you have messed up? I don't know. No. Abdurrahman, am I audible?
Yes, sir.
See, in the first question, what you have to do? You have to break the C double bond C. In that, you have to break the pi bond. So what will be remaining? This structure will be remaining, yes or no?
Yes.
And what are the carbons where you have broken bond? This carbon and this carbon, right? Yes or no?
Yes.
So there you have to add Br. है ना? See, you have not added there. You have added somewhere else. You have added here. Did you see that? Yes or no? Tell me. And also see, make the
Yes.
bonds very proper. Okay, this itna small bond mat banaiye, itna chota. The other bonds are like very large, and you have drawn Br and these things with very small bonds. Similarly, what will be for chlorine? Everything as it is. Break the pi bond. Add a chlorine here. Add another chlorine here. Got it?
Yes, sir. Got.
For the third question. You don't have your phone number. You don't have my Umar.
What, sir?
I have your number, na?
Sir, but that mobile is with my mother right now.
Oh, okay. Save this. Oops, sorry. Wait. Don't save this one. Wait a second. It should be +91. Save this. Now, all of you look at the third one. In this also, Abdurrahman, kya karna tha? You see where is the mistake? Yes, Abdurrahman, tell me.
Yes, sir.
So you have to draw as it is. Then wherever the carbon-carbon pi bond was there, you have to add Br like this and Br like this. Okay. The pi bond is breaking and the CX bond is getting formed. Sahal, did you get this? Yes or no? Tell me.
Yes, sir, I'm just writing it down.
Okay. It is a simple reaction. Then we will move forward to a complex one. Fourth, I will discuss. Okay. Let Sahal write, all of you. And let me get the photos from Muhammad Umar, the answers from Muhammad Umar, and then I will discuss the fourth one. What is different in the fourth one? Tell me, what is different?
That's UV radiation.
The H nu. H nu is different, right? Everything else is same. H nu is different. Okay.
So
Now,
follow the anti-monoclonic rule or something.
No, see, Markovnikov's rule. एक चीज मतलब ये ऐसा ना टर्म याद करके ना बोलना नहीं चाहिए. ओके, व्हाट इज एंटी मार्कोनिकॉव रूल? डू यू रिमेम्बर? ये बताइए पहले.
Yes, sir.
हाँ बताइए, व्हाट इज एंटी मार्कोनिकॉव रूल?
Sir, the negative part of the addendum,
अडेंडम. व्हाट इज अडेंडम?
the adding molecule.
रिएजेंट. रिएजेंट है ना, रिएजेंट.
Yeah,
सिंपल टर्म्स
reagent.
है ना. अच्छा, सो नेगेटिव पार्ट क्या होगा? Br2 तो आपका क्या है? इट इज नॉन पोलर, राइट? Br and Br both are having same electronegativity. It is
Okay,
a symmetrical. It is a symmetrical reagent, right? So that is why
Yeah.
no Markovnikov or anti-Markovnikov here, right? ठीक है.
Okay, sir.
So let us leave this. It is not Markovnikov or anti-Markovnikov. It is related to our last topic that we have learned. See, HNO is present. That means what can happen? Halogenation.
Sir,
Tell me.
so did you receive my answers?
Your third one is not right. Now you have missed the CH3. Others are fine. See the third one.
Okay,
आप
sir.
CH3 लगाना भूल गए, देखिए, है ना. Others are fine. Okay. So Matthew and Adriel and Umar, you guys remember halogenation of alkene? What does it require? It requires Br2 or some halogen with H nu. Any free radical generator. Now what will happen? Even though this is alkene, one of the pi bond is present, but all of these will act as what? sp3 carbons. All of these three. Yes or no? Tell me. Correct? Arey haan hai na? What happened? No. Just ignore the pi bond for once and tell
Sir,
me.
can you repeat?
I'm asking. Ignore the pi bond for once and see all of these white I have labeled as 1, 2, and 3. All of them are sp3 carbons. Yes or no?
Yes, sir.
Right. So sp3 carbons, that means these are alkanes. Correct. These, if I just talk about this carbon, it is what it is. Saturated carbon atom. This is unsaturated. This is unsaturated, but this is saturated. So what can happen? This can act as what? This can act as a substrate for halogenation of alkene. And also you know that there will be 2 hydrogen atoms attached on each of the carbons because it is making 2 carbon-carbon bonds. So the remaining valency, that is 4, will be satisfied by hydrogen. You all know number of hydrogen is equal to how much? 4 minus number of bonds. Number of hydrogen in a bond line structure is equal to 4 minus number of bonds. Okay. So from here we have hydrogens also. We have our reagent Br2 also, and we have the free radical generator, that is H. If you remember, helper. In helper, what do we have? The light is H, right? This is H. Okay, so what will happen? You can have free radical halogenation. Now the question is, where we will have free radical halogenation. So I will label this as first carbon, this is second carbon, and this is third carbon. But you may see that the first carbon and the third carbon are the same. Yes or no? Look at the linking.
Because they're close to the bond, double bond.
Their environment is completely same. Sahel, आपको आ रहा है? Yes or no? Tell me, Sahel.
थोड़ा थोड़ा है.
थोड़ा आ रहा है. अच्छा. Oh, you must have not completed the all lectures, na? Abhi?
Yeah, no, I just have one more to go.
Okay, one more to go. Usi mein hai, I think, this preparation from alkenes, I think. Okay. So here what we can see that first carbon and third carbon are same. So I will ignore the third one. And what I will say, let us make free radical on the first and second carbon. Let us see which is more stable. If I have a free radical here, and if I have a free radical here, what is the difference? The difference is this red free radical is taking part in resonance, that is A double bond B. This is A double bond B, single bond C, and C has a free radical. Now this will be more stable. This red free radical will be more stable rather than the green one. So the product will be formed like this. This pi bond is not reacting at all. It is not taking part in reaction. Reaction kiska ho raha hai? sp3 carbon. It is of alkene. So you will have a product like this. The pi bond is as it is, and you will get a Br here. Okay. So please make sure whenever you have a halogen, that means you have Br2 or something, Br2 or Cl2, and there is H nu, then you will take care and you will do the halogenation of alkene rather than any reaction at the alkene carbon. Okay, so please note that. You will note when halogen is treated in presence of H nu, है ना, or light, you can say both are same things.
So, sir, you will have both major and minor products.
No major. You will. This will be very less. Na? Resonance को कौन compare कर सकता है? I mean, no one can beat resonance. So you will draw this product only. Okay. You can have other product. ये वाला भी. This product will be also there, but it will be very minute because it is resonance here. है ना? So the stabilization that molecules they get from resonance, it is like what I can say. You can compare resonance as a bucket. Then we have hyperconjugation. If you remember hyperconjugation, that is like a mug or jug. And then this carbon will be stabilized through inductive effect. Inductive effect is just like a spoon. So resonance is highly stable. Okay. Remember that. H nu, then check if any sp3 carbon is present on adjacent to लिख लीजिए, adjacent to the carbon double bond. Okay. Now if sp3 carbon is present, then what you will do? You will do the free radical halogenation. Done everyone? Yes or no? Please tell me.
Sir, I'm still writing.
Okay.
So can you explain what is resonance?
Resonance. नाम याद आ रहा है आपको या नाम भी याद नहीं आ रहा 11th क्लास से?
मुझे याद नहीं आ रहा है.
अच्छा, no, you don't even remember the name कि
No,
resonance
I
कभी सुना भी
remember.
नहीं?
No, I know the name, and I
You know
also
the
know like it's like.
कुछ तो stability है, right?
Maybe I'm not clear.
Not clear. Okay, see. The only thing that you have to do is to identify resonance. So identification of resonance will be A double bond B, single bond C, and this C can have a free radical or a lone pair or a positive charge or a negative charge or a double bond further on. Okay, double bond. So if you get any of this, you get A double bond B. So as if you look at the intermediate here, it will be like this. The intermediate of this reaction will be like this. So can you see that there is A double bond B, single bond C, and there is what? A free radical. Yes or no? See, A, B, and C has a free radical. दिख रहा है Sal now?
Yes, sir.
So now, for as of now, what you will say, whenever you have this type of situation, this will be more stable, very stable.
Okay.
Okay. These type of intermediates will be easily formed. Fine. Why it is happening? Because all of them, they take part in resonance and this pi bond will delocalize. And see, whenever you have charged species, they want to be spread around in a large area rather than concentrated in a very small area. है ना? So देखिए क्या होता है, all of you know ना, if I have a energy na, it is always spreading around. If I heat a rod, if I heat an iron rod at one side, slowly what will happen? This heat will spread out. Yes or no? Correct. So what is spontaneity? Spontaneity में क्या होगा? Whenever anything is having some kind of charge or something, right? So electrons are what? Electron density is what? It is charge only. So pi bond is here we have high electron density. If we have lone pair or if you have positive charge, so all of these are telling you about charge. Whenever you have this type of resonance, the charge gets spread and that is why it is more stable. ठीक है? इतना अभी ठीक रहेगा? याद कर लीजिएगा इसको सर.
जी सर समझ में आया.
Okay. Done? Umar, yes or no, tell me?
Yes, sir.
Okay, see. So can write a reaction like this. You have the same molecule, cyclohexene, but when you treat this with Br2 in dark, and when you treat this with Br2 in light, there are two different products. In dark, you will be getting Br and Br, and in light, what you will be getting? Free radical halogenation. ठीक है? This is Br2. Done, everyone? Yes or no? Please tell me.
Done. Sir.
Done. Should we move forward? All of you are done now? Okay, now right?
Done.
Okay. So the second reagent that we use is, first was halogen. Now we are using hydrogen halides. Hydrogen halide is HF, HCl, HBr, HI. Okay, so all of these are what? Hydrogen halides. Please write with me. When alkenes are treated with hydrogen halides, they form corresponding alkyl halide. They form corresponding alkyl halides. In this case, you have C double bond C, plus we have HX. Now here what happens? One of the carbon, it gets the hydrogen. The other carbon, it gets the halogen. So you will again write C double bond C, pi is broken, then CH is formed, and CX is formed. So please write this down. Let me know when you're done. Then we will look at the mechanism, and we will see there will be some cases in which you can't decide where you have to put the hydrogen, where you have to put the halogen. Okay. So So you write it like this. For example, you have CH2, double bond CH2 plus HBr. Then what is going to happen? See, now both the carbons are same, so you can add hydrogen anywhere and bromine anywhere. So you write it like this: CH3. Let me add CH2 in the second carbon. It is not going to make any difference because what? Because both of the carbons are same. Similarly, if you have CH3, CH double bond CH, single bond CH3 plus HCl, let us have. Now here also, tell me, are both of these carbons same or different? What do you think, guys? Sahel, aap bataiye. What do you think? Both of these carbons are same or different?
Same.
Same, right? So these are same, and what will happen? You can attach CH2 hydrogen in any one of it and bromine in any one of it. So we'll get CH3, CH2, CH will get, let us say, Br, and then we will have CH3. Okay? Write these examples fast, and then we will look at a case in which both the carbons are not same.
Cl, right?
Cl hoga, my bad. Done, everyone? Yes or no? Please tell me.
Done, sir.
Okay. Umar, done? Yes, Umar? Okay, what happened? Adriel got disconnected. Okay. See, let us have the reaction like this. CH3, CH double bond, CH2. Now tell me, Sahel, are both the carbons same or different? Are they same or different?
Which both, sir? This one and?
I mean, the carbons, you have to look at the double bond. In double bond, you will be, so those carbons are these two carbons, they are same or different?
Carbons. No, those are different, right? CH2 and
CH2 and CH, right? I mean,
yeah,
this is visible. They are different.
Yeah.
Okay. Now what can happen? You can, if you have HBr, so let us say what is there. You have HBr. So H can attack here and Br can attack here, or you can have a opposite case in which the Br is attacking here and you are getting H here. So I'll make both the products. Okay. So just in case, not to confuse very much, I will just say that Br can attack once here, or it can attach the second carbon. These are the only two options. And in the other doubly bonded carbon atom, you will add the hydrogen as it is. Okay. So let us take the first case in which we are having CH3, CH, Br, and in the next carbon, I will add the CH3. It will be like, I will be adding the hydrogen. Plus, now this is the second case in which we are having CH3, CH2. I've added the hydrogen here because bromine will be added in the next carbon. CH2Br.
Sir, are we
Now,
using the Markov-Niels rule here?
नहीं कुछ नहीं यूज कर रहे ना, उसको छोड़, जो नहीं अभी नहीं पढ़ा है ना, जो अभी तक हमने नाम लिया उसको हम क्यों यूज करेंगे? ओके, रूल क्या है बताइए तो. आई मीन सी, एक तो ये दिक्कत है ना कि where that rule comes from, उस रूल को अभी छोड़िए आप. ओके, all of you leave that rule. Okay, and let us see why that rule is true, why that rule is true and why it is happening like that. So for that, we have to look at mechanism. Now, what we have two different types of product in which what we have to do, we have to see which of them is going to be major and which of them is going to be minor. So we have to look at the mechanism.
So can you just repeat a little bit? I got disconnected.
Okay. आप यहाँ तक थे, ये सब लिखा है आपने?
No, sir.
नहीं. Write this down. I was saying that when you have same type of carbon atoms, then it is not a problem. You can add the hydrogen anywhere and the chlorine or the bromine anywhere. But if when you have different types of carbon atom, then you can get two different products on addition of bromine and hydrogen, right? On addition of halogen and hydrogen, as we have done in this one. So now we have to look which of them is going to be major and which of them is going to be minor. Write this down, Adrian. Done. Yes, Adriel, done.
Yes, sir. Yes, sir. Done.
Okay. So see, now in mechanism, we will first start with our substrate, that is CH3CH double bond CH2. Plus HBr. Now we know bromine is more electronegative, that is why it will be delta negative and it is delta positive. And in the alkene, we have a high electron density at what? At the pi bond here. This pi bond will be having this will be electron rich and it will be electron source. Then it will attack on hydrogen because hydrogen has a delta positive charge. It is a electron poor species, and alkene is what? It is a site of electron richness. And what you will be getting a product like this. Now when hydrogen is getting electron, what it will do? It will lose the electrons of Br like this. So Br will be getting both the electrons of the bond. And now what can happen? You can form two different types of product. Now when the alkene, it is getting attached with hydrogen, it can attach either via the CH carbon or the CH2 carbon. So you'll make two different products from here. Either CH3, CH2, and CH2 positive can happen. That means where we have added the hydrogen in the second carbon. Or what else can happen? You can have CH3, CH, CH3, and there will be a positive charge in the second carbon. So this is 1 degree carbocation, and this is 2 degree carbocation. So obviously, which is more stable? This is more stable. And since this is more stable, this reaction will be preferred, and there will be a lot of intermediate, which will be 2 degrees, and then the reaction will continue from this point, that is 2 degree carbocation, and you will be having CH3, CH positive, CH3 plus. Now from here, what are we getting? Br negative, right? So this Br negative will be there. And now Br negative is what? It is electron source, because it has negative charge. It will attack on the CH carbon, and you will be forming CH3, CH, CH3, and Br. Okay. So this is how the major product is formed. Now, this is major. This is minor. Please write the mechanism. And this is the origin of Markovnikov's rule. Okay. The stability of carbocation. The stability of carbocation is the origin of Markovnikov's rule. Write this down, then we will write the Markovnikov's rule. Any doubt in this? Adriel, Muhammad Umar, Abdurrahman, Sahel. Any doubt in these two steps? You guys are with me, right? Yes or no? Tell me. Hello, am I audible? ये दो स्टेप समझ में आए? Yes or no? Abdurrahman, please tell me.
Yes.
What about Sahel?
Fine, sir. समझ में आया.
Okay.
So then we can say like the hydrogen goes to that molecule, which I mean that CH atom where hydrogen is the most, right? जहाँ पर hydrogen ज़्यादा होता है, and the halogen goes to where the hydrogen is the least. Can you see like that?
Yeah, that is the Markovnikov's rule. That is how Markovnikov proposed it. It is a generalization, but you know that there is an anti-Markovnikov's rule also, right?
Yeah, which is opposite of that.
So obviously it is a generalized version. Now I will tell you the story, because Markovnikov, when he was doing the reactions in day, he was getting some different product as major, and when he was doing at night, he was getting some different product. So it was only because of the free radical. Free radical can be generated with peroxide. Now peroxide is more effective, but if you have enough sunlight also, then also you will be getting the same peroxide effect. Okay, so that is why, then Markovnikov, he was not able to understand. Okay, whatever I'm saying, it is just, I have heard this, I have not read this anywhere, but I have heard this from chemists that Markovnikov did not know what is happening here. Okay, so Kharash, he was a scientist. He was also from what is right now Ukraine. Markovnikov was also from Russia, but at that time everything was USSR, the Soviet Union. That is why I think both of them, they were in the same university or department. And Kharash, he asked for the notes of Markovnikov. So Markovnikov gave the lab journal. So when Kharash saw, okay, he's getting some products at day and some different product at night, then he worked up with the peroxide effect, and that is why it is also known as Kharash effect. It has three names. It has anti-Markovnikov's rule, Kharash effect, peroxide effect. All of these three names are valid. So Kharash comes in only because he took the notebook, lab journal of Markovnikov, and then he found out, okay, fine, and he gave the explanation that it is due to the peroxide. All of you are done? Yes or no? Please tell me. Is everyone done? No.
Yes.
Still writing. So write next the Markovnikov's rule. Please write with me. When an unsymmetrical alkene is treated with unsymmetrical reagent, then the negative part of that reagent that reagent can say attaches with that doubly bonded carbon atom which has what? Which has lesser number of hydrogen. Okay. After this, we will write the anti-Markovnikov's rule. When an unsymmetrical alkene reacts with HBr in the presence of peroxide or light, peroxide light, what they will do, they will help in the generation of free radicals. Then the Br attaches on that doubly bonded carbon atom, which has more number of hydrogens. Write this down. Let me know when you're done. Please remember, the peroxide or the light, it is only able to break down. It is only able to break down in appropriate time the HBr bond. Okay, not any other bonds. That is why when you इतना ही याद रखिए आप लोग, बस ये आएगा, उससे ज्यादा आप लोग को पूछा भी नहीं जाएगा वैसे भी. That is why anti-Markovnikov rule, it is only for HBr in the presence of peroxide or light. If it is HCl or something else, then it will be what? Even in the presence of peroxide, it will be giving you the Markovnikov product. Oh, symmetrical and unsymmetrical reagents you want to know? See, unsymmetrical reagent which will have some kind of polarity. If polarity is there, that means it is unsymmetrical. And delta, that means they have different atoms. Okay, they will have different atoms. And symmetrical reagent, they will have same atom. For example, Cl2, Br2, I2. These are examples of symmetrical reagents. Okay, and what did I say right now? Can you repeat what you just said? I said that anti-Markovnikov rule is only applicable for HBr, not any other reagent. Only for HBr you will be doing anti-Markovnikov. और आपके इस एग्जाम में you will be only getting HBr and peroxide. किसी दूसरे के साथ देंगे भी नहीं वो. Okay. Done? Yes or no, please tell me.
Good, sir.
Done, sir.
Write it fast. Adriel and Abdul Rahman, you guys are done?
Yes, sir.
Mohammed Umar, write fast.
Done, sir.
Okay. Write some questions. Don't just write the questions, okay? Can you write all of these questions? All of you wrote the question. Yes or no? Please tell me. Are you guys done writing the questions? No. What happened?
Yes, you're done.
Done, no? What about others? Adriel, Abdurrahman?
Done, sir.
Yes,
Done?
sir.
Okay. Take care. See. So the only thing that what you have to do, you have to see whether you have peroxide or you don't have any peroxide. Okay. So first is what? Tell me, it is symmetrical or unsymmetrical? This alkene is symmetrical or unsymmetrical? What do we think? Symmetrical or अरे देखिए इतना आसान है, symmetrical unsymmetrical पहचानना है. Just draw a line across the double bond. Symmetrical or unsymmetrical? What do you think? No idea. Symmetrical, unsymmetrical. आप लोग को Abdurrahman, Adriel, what is happening? Huh?
So unsymmetric.
Unsymmetrical, right? Okay. Just wait a second. Sorry for that. Okay, so it is unsymmetrical. HBr is obviously unsymmetrical because it is having two different atoms. The electronegativity will be different, and they will be having some dipole moment here. Now, how many hydrogens are here in the blue carbon, and how many hydrogens are here in the green carbon? Okay, so similarly, you have to calculate all of these things. Here and here, how many will be there? Tell me for the blue one. Sahel, can you tell me how many hydrogens will be there in the blue carbon?
How many hydrogen, right?
How many hydrogens?
Okay, so
It is 4 minus number of bonds.
yeah.
You can. Okay.
How many bonds are there? Double bond. 2 will be there, right?
नहीं देखिए टोटल नंबर ऑफ बॉन्ड्स देखिए ना, चारों तरफ देखिए, एक ही तरफ मत देखिए आप. How many bond it is making?
If already 4 bonds, it's me.
Already 4 bonds are here, so
Yeah.
the number of hydrogens will be how many?
0 then. Only
Zero.
okay, only 0.
0. And here?
Here it will be 2 bond here left, and then okay, one hydrogen.
1 hydrogen. So you tell me HBr. अब बताइए Markovnikov, anti-Markovnikov.
It will be Markovnikov.
Markovnikov. So which it will attach on the blue carbon or the green carbon?
Will attach on the BH will okay. Hydrogen will be attached.
Br.
Br will be attaching on the blue one.
Blue one. Okay. Abdurrahman, Adriel, Muhammad Umar. Got this?
Yes, sir.
Yeah, once more.
Yes, sir.
Yes. Abdurrahman, what about you? Once more?
Yes, sir.
Okay, once more. You tell me now. How
No, sir,
many?
I understood.
Understood. लिख लीजिएगा प्रोडक्ट. इसका बता दीजिए आप एक बार. और how many hydrogens are here in the green carbon? Abdurrahman, tell me. Abdurrahman, your mic is off. 2. कैसे कैलकुलेट कर रहे हैं बताइए. नंबर कितने बॉन्ड्स हैं उस कार्बन के पास? काउंट ऐसे उंगली रख के 3 बॉन्ड्स. सो नंबर ऑफ हाइड्रोजन्स कितने हो जाएंगे?
1, so 4 minus 3 1.
ना ठीक है, एकदम उंगली रख के काउंट कीजिए. ठीक है, ऐसे. ओके, व्हाट अबाउट हियर? हाउ मेनी? काउंट 1 2 ऐसे देख के कुछ नहीं आएगा. 1 2 3 ऐसे करके काउंट कीजिए. या
So 3 bonds. So
फिर काउंट किया आपने, उंगली रख के काउंट किया स्क्रीन में, या फिर आपने बनाया हुआ है मॉलिक्यूल?
No.
है ना? सो
Yes, 0.
अब बताइए मार्कोनिकॉव, एंटी मार्कोनिकॉव.
So anti-Markovnikov.
Okay, so it will attach on which carbon? The carbon which is having more
number of hydrogen atoms at 1 green.
1 ग्रीन। ठीक है, चलिए। सो इसके लिए भी आप लोग कर लीजिएगा। चलिए प्लीज राइट द प्रोडक्ट फॉर दीज 3। Done everyone? Yes or no? Please tell me. Yes, guys, done? Not done? Not done.
Done.
Done, na? What about others? Abdurrahman,
Yes.
Muhammad Umar, Sahel. Send me the photos. Send me the answers. WhatsApp me. Okay, Sahel, I have got yours. No, this is Muhammad Umar.
I'll send you. I just have to get my profile. Once
Okay.
slip number.
मोहम्मद उमर मार खाइएगा आप। मोहम्मद उमर, उमर, आर यू देयर?
Yes, sir.
हाँ, उमर, उमर, उमर।
Yes, sir.
हाँ, सी द सेकंड वन। मिथाइल से आपको इसका CH3 से क्या दुश्मनी है आपको? Why do you miss the CH3? In the product देखिए, प्रोडक्ट में देखिए। ओके, काउंट द नंबर ऑफ कार्बन एटम्स। ये फर्स्ट वाला प्रोडक्ट भी आपने गलत बनाया हुआ है। कैन यू सी दैट? You have missed this carbon atom, the CH3. Here you have 1, 2, 3, 4, right? And you have just drawn 3 carbons there. दिख रहा है मोहम्मद उमर? yes or no?
Yes, sir.
चलिए, सी वाला सही है, इसमें कुछ आपने मिस नहीं किया है। Waiting for Adriel and Abdurrahman. Okay, Adriel, have got yours. करेक्ट, वेरी गुड।
सर हाइड्रोजन ऐड करने के लिए खाली लाइन डाल के बस ऐड कर सकते हैं?
हाइड्रोजन नहीं, हाइड्रोजन इसमें ऐड ही नहीं करना है ना, यही तो सबसे अच्छी बात है बॉन्ड लाइन स्ट्रक्चर की। देखिए पहला जो प्रोडक्ट
Okay.
बनाइएगा ना,
ओके ओके ओके,
you will-
हाइड्रोजन ऐड नहीं करना था
हाँ,
मैं।
हाँ, you just need to show that where is bromine getting added, that's it,
ओके
like this. Abdur Rahman, I've got only one answer, Abdur Rahman. बाकी नहीं कीजिएगा क्या? बाकी नहीं लिखा आपने क्या?
Yes, sir, sending. I wrote on the last
हाँ।
page, sir.
अच्छा अच्छा, since most of you have given the answers, let me write the answers here like this. CS3 will be as it is, the bromine will getting attached here. So it will get to the attach here. ये देखिए ये लाइन थोड़ा बड़ा बनाइए है ना अब्दुल रहमान, दिस बॉन्ड, राइट? देखिए बहुत छोटा बनाया हुआ आपने, ऐसे बनाया हुआ, राइट? तो दिख नहीं रहा है बिल्कुल। चलिए, by the way, have we done Sandmeyer's reaction here? Sandmeyer's reaction? No, na? Sandmeyer's reaction? No.
No, sir.
Okay. Write the next one. Sandmeyer reaction. Please write. When benzene diazonium chloride is treated with cuprous chloride or bromide, then it forms chlorobenzene or bromobenzene, right? If cuprous chloride is used, then it will be forming chlorobenzene. If cuprous bromide is used, then it will be forming bromobenzene. What is the reaction? Benzene diazonium chloride. So benzene is benzene. Diazo means N2 positive, diazo, and chloride is Cl negative. When this react with Cu2Cl2, or somewhere you will also see CuCl. Okay, so both are fine. What you will be getting? You will be getting here chlorine.
Chlorine. So what happens to N2?
N2 gets, wait a second. N2 nitrogen gas बन के निकल जाता है. Nothing happens to N2. Got it? Done, isn't it? Tell me.
डन सर।
Okay. So next is how do we form this benzene diazone? Is anyone seeing something?
Yes, sir.
Tell me.
Can you scroll up?
Scroll up.
Yes, sir.
कितना up?
Yes, sir. Done, sir.
Done, no? ओहो सहल, आपके सारे आंसर्स गलत हैं। सहल,
जी सर।
ये लिखा आपने, पाई बॉन्ड ब्रेक करना होता है ना,
या आई रोट दिस।
तो फिर पाई बॉन्ड ब्रेक क्यों नहीं किया आपने?
ओके ओके।
ठीक है, ध्यान रखिए इस चीजों का। या ना, how do we prepare benzene diazonium chloride? So it is also important. We prepare this from aniline, and actually this reaction happens like this. We take aniline, benzene diazonium chloride. It is very unstable, and we start with aniline, that is benzene ring in which we have NH2 attached, and then we add NaNO2 plus HCl, and this should be done in 0 to 5 degrees Celsius. So we used to have a tub. In the tub there was ice, right? And then the beaker is set up inside the ice like this. And here we prepare the benzene diazonium chloride reacting with aniline, and then we have NaNO2, and then we add HCl. And then what you will be getting, you will be getting benzene diazonium chloride, that is BDC. Okay, and then further what we will add, after we have added this, then what we are going to add, we are going to add Cu2Cl2. Okay, and you will be getting chlorobenzene. So this question can also be asked in a way that how will you bring out the following conversions? Aniline to chlorobenzene. This is the first conversion that you can do in haloalkane haloarine, aniline to chlorobenzene. Please write this down, the last reaction. Benzene diazonium chloride is highly reactive. Done guys, yes or no, please tell me. Can I move on? लिख लिया हाँ या ना, जल्दी बता दीजिए क्या हो जाता है आप लोगों को. Let me know if you have not done. चलिए, please write. The next method of preparation, that is halogen exchange methods. So we have done till now how many name reactions? We have done one name reaction. Now comes the other name reaction. Halogen exchange method, these are two. Finkelstein reaction. Second is Schwarz reaction. Write the number one, Finkelstein reaction. Finkelstein reaction. Write the statement for this. When chloro or bromo alkanes are treated with sodium iodide in the presence of dry acetone. Dry acetone is just a solvent. Why are we using dry acetone? Because sodium will be in the form of sodium positive and it will react heavily with water if we have any moisture. So dry means it is there is no moisture present. Okay, presence of dry acetone, it leads to formation of, it forms what it will form, iodoalkane. Iodoalkane. Okay. So if we have Rx, where X will be what? Chlorine or bromine. The sodium iodide is going to give you Rx, sorry, Ri plus NaX. Write the product for this.
Sir, what is the X is equal to CF?
Cl and Br, comma Br.
Okay, okay.
Done.
Yes, sir.
Right, next, Schwartz reaction. So Schwartz reaction is, please write, when alkyne halide alkyne halide, I mean chlorine or, okay, chloride or bromides. Wait a second. Are treated with metallic fluorides they form alkyne fluoride. Okay, so you have Rx. Again, here X will be what? Either chlorine or bromine plus metallic fluoride, Mf. Okay, and I will tell you what are these metallic fluorides that you can use. You will be forming Rf plus Mx, you can write in general. So this metallic fluoride can be, most importantly, you will be using AgF. ठीक है, AgF हमेशा याद करके रखिए. Then you have Hg2F2. This is the next common one. And at last, बहुत दिमाग खराब हो गया टीचर का, तो आपको SpF3 दे देगा. ठीक है. So whenever you see anything that is having alkyne halide plus a fluorinating agent, that means you have fluorine somewhere, then you will be forming what? Alkyl fluorides. Okay, write this down. Also write an example. Let us say you have something like this. So you have, let us say, CH3, CH2, OH, and you have to form CH3 CH2 F. So the first reagent you will be using is SOCl2. यहाँ पे, when you use SOCl2, what will happen? You will be forming CH3 CH2 Cl, and after that, what we will be using? We will be using AgF. Will be giving me, so generally fluorines are and alkyl fluorides and iodides, they are made using halogen exchange method. The other method, they are not very, I can say, they are not very efficient in that sense. Okay, so first of all, we convert whatever substrate we have, such as here we have alcohol, and treat it with thionyl chloride to get pure chloroalkene, and then we treat it with AgF or Hg2F2 in order to get fluoroalkene. Also, it is kind of an expensive reaction here, because you see Ag, Hg, antimony, all of these are precious metals. They are costly. Actually, write this down. Let me know when you're done.
So ये class कब तक चलेगा? I have to join the physics trial class, I guess.
हाँ, हो गया बस.
Okay. Like Monday and Wednesday, I have to join with chemistry with you, right?
Yeah, for chemistry.
4:30 Saudi time.
नहीं, 4.
At 4, okay, 4.
4, हाँ, 4 Saudi time ना.
Okay.
ठीक है.